Imagine you are lost in the mountains at night. It is pitch black, and you cannot see a thing. You know your village is at the very bottom of the valley, but you have no map. How do you get there? You feel the ground with your feet. You find the direction that slopes downwards the steepest, and you take a step in that direction. This simple intuitive strategy is the core of one of the most powerful algorithms in machine learning: gradient descent. In the world of mathematics and machine learning, this landscape is defined by a cost function. Think of the surface you see here. The height at any point represents the error of our model. The higher we are, the worse our model is performing. Our goal is to reach the lowest point, the global minimum, where the error is zero, or as close to zero as possible. But how do we know which way is down if we only have math? We calculate the gradient. The gradient is simply a vector that points in the direction of the steepest ascent, uphill. So, to go downhill, we just take the negative of the gradient. It acts as our compass, telling us exactly which direction to step to reduce our error. Scenario 1. The learning rate is too small. Here, our algorithm is being extremely cautious. It takes tiny, microscopic steps. While this is safe, we are definitely moving downhill. It is agonizingly slow. In a real machine learning problem with millions of data points, this could mean waiting days or weeks for a model to train.